And once again, just for the recording here, we're finding the concentration of the drug after it's in the bloodstream for 1 hour, right? And so we're told the concentration C of a drug in the bloodstream T hours after the drug was taken orally is given by this, where C is measured in milligrams per liter, okay? And so after 1 hour, we're going to plug 1 in for time there, okay, and just simplify, okay? And does anyone have an answer for us? Anyone get to plug it in their calculator yet? Because that's another thing too, right? You guys got to type this in and do it accurately too. I'd recommend you maybe type it in right now and give it a try, all right? If you can't type this in your calculator accurately, it doesn't matter that you have your calculator to help you, right? You are the user. You got to type it in accurately here, okay? So I would suggest you type it in. And again, using parentheses around the numerator, parentheses around the denominator too, okay? Otherwise you might get it wrong. If you want to, you can, or you can just, so you could in the numerator, let me show you what I'll say. Good question. So like you could, for example, do like parentheses 5 times 1, right? Because 5 times 1, that is what you've got right here, right? It's really just 5 times 1. So you could just write that and then divide by, and then, 1 squared plus 0.25, something like that, and then minus the 0.75 at the very end there. Okay, and you should get 3.25 as your answer there. 3.25 is your answer. Actually, that's not rounded. It's exact. Yes. Alrighty, so letter B then. At what time is the concentration in the bloodstream the strongest? Round to the nearest 100. Okay, so how can we go about doing this? We want to know when the concentration is the strongest. What can we do to figure that out? Look at the table. So that means we need to put in y equals, right? We have to put it in y equals, right? We're gonna put in our y equals. So that's what we'll do here. So y equals, right, parentheses around the 5, the 5x or 5t. In fact, I can zoom in some here, I guess, now. Okay? And then divided by parentheses around the denominator, so x squared plus 0.25, and then minus 0.75. Okay? This is also a way, so, we mentioned the table here, right? This is also another way you could evaluate at 1, right? There's the t or x value of 1 there, and there's your matching y value, 3.25. Okay, if you highlight that 3.25, you can see it's not rounded. That is exact 3.25. So
you just type it in and look at the graph?
Go to the second graph, and you go to the table, and that'll give you, at least for letter A, you can also see at 1 what the value is, too. Okay. You can also, if you have the graph, and there's our graph, you can actually evaluate a function using your graph, too. If you press second trace, this is a command that I haven't shown you guys yet, because there's so many other ways to do it. It's not super necessary. Can't hurt to show you this, though. You can also use the value command. So if you hit enter there, okay, and you have your graph up, you see how it's waiting for us to type in an x value. Well, if you type in an x value of 1 and hit enter, the graphing calculator will locate that point at when x is 1, and it'll give you the matching y value there too, f3.25. So that's yet another way for you to evaluate a function if you type it in your graphing calculator and stuff. Okay? Now, more importantly though, let me go back to the graph. Okay, we can also see on the graph here where our highest point is. It's right here, right? So we want to find the location of that point. You guys remember what command can we use on our graphing calculator to find this point right here? Maximum, yeah. Second trace and go down to the maximum command. Okay, and again, your calculator leads you through it, right? It says left bound, question mark. So you want to make sure you use the left and right arrow keys to move to the left of that maximum. Then move your right arrow key to move to the right of the maximum and hit enter again. And then for the guess, move it in close to the top, which is probably like right there maybe, and hit enter for the guess. And voila, there's your maximum. Now, this is a bit of a rounding error here on the calculator's part. Okay, your calculator's not a perfect machine, right? It's programmed and stuff like that. And so we're going to say this is really 0.5, comma 4.25. Okay, so it's going to be happening at 1/2, comma 4.25. Okay, And so what time then is the concentration in the bloodstream the strongest? What time? It shouldn't be. I would say you want to recheck how you typed in your things in your graphing calculator there. All right. Should have. Do you have the maximum command? It gave you 5?
Yeah.
All right. I'll come take a look at it here in a second and see. But let me finish answering this question here real quick. At what time is the concentration in the bloodstream the strongest? What does our point tell us here? What's the time when the concentration in the bloodstream is the strongest? What's that? Half. Yeah, 1/2 of a hour. So you can say half an hour after taking, the pill or the drug. Okay. Half an hour after taking the drug is the maximum. Okay. All right. Let me go check here with. You got everything else typed in right, and that's important, right? So just don't forget that other 0.75 there at the end, minus 0.75. Okay, letter C, calculate the average rate of change. Folks, when we see average rate of change, that is really referring to the, one second, Mike, let me answer this question. Okay, slope formula. So it's f of b minus f of a over b minus a. In this case, what are our b and what is our b, what is our a? What are our x values that we're given? 0.5 and 1, exactly right. So this is going to be, I'll do 1 minus 0.5, and then on top, and then I'm going to use, instead of f and f, it's c, right? Our function is c. So I'll say c of 1 minus c of 0.5. Okay? Now the beauty of this is we already know what c of 1 is. We found that in part A, right? C of 1 was 3.25. If we didn't know c of 1, we could go to our table, or we could use the value command, or we could, just plug it in, stuff like that. We also know what c of 0.5 is, right? We found that right here. It's 4.25. That's kind of lucky. I don't know if they designed the question that way on purpose, but and then 1 minus 0.5 is, that's 0.5, right? And so 3.25 minus 4.25 is going to be negative 1 over 0.5, which simplifies to negative 2. Okay, so negative 2 is our answer there. Okay. I'll ask one more question here, Mike, then I'll get you, okay? Why does it make sense that we have a negative average rate of change here? Why does it make sense here that we have a negative rate of change? What's happening that would indicate that we should have a negative rate of change here? What's that? Drugs leaving your system, exactly right. Okay, exactly right. Remember that this average rate of change here, it's an average rate of change from the maximum point, right, when the drug reaches maximum concentration to then a later time. And so if the drug has reached maximum concentration of 0.5 and then you go later, we would expect that the drug's concentration in your bloodstream would decrease, okay? Prior to reaching our maximum, concentration, we would expect an increase, right? Because, you're building up to that maximum. All right, sorry. Mike, you had your question. What was the question? You typed it in incorrectly? Yeah. Let me take a look at it then. Oh, yeah. So for our purposes, since we're just trying to graph it now, you want to put the actual x in there. That's all. And then I think everything else should look good. Okay. So for the first part, Mike, we plugged in a 1 just because we were evaluating it at 1. But then when we want to go to graph it, you want to make sure you put the x's in there and stuff. Gotcha. All right, letter D. Interpret the meaning of your answer in part C, include units. So there it is, part D right there, okay? The concentration of the drug is decreasing by 2 milligrams per liter every hour on average, we'll say. Okay? Because in truth, the rate of change, okay, the rate of change of the concentration of that drug, it's changing too, right? It's not always going to be going down by 2 milligrams per liter every hour, right? It's going to be different depending on, where you are in the process and stuff like that. All right. Okay. Notice I didn't need to use a negative here because I said it was decreasing. So when you say it is decreasing by this, by a positive 2, that means you're really going down, right? Be careful. Don't use like a double negative there. If you said decreasing by -2, you're kind of getting into like double negative territory where it's like, it kind of like means that it is increasing by 2, right? If you decrease by -2, that's really increasing by positive 2. So be careful with that. Anyway, letter E. After how many hours is there no drug left in the bloodstream? Round to the nearest hundredth. Okay? So let's take a look here. Where are we going to be looking on our calculator, on our graph here? Where do we want to look to see where the drug is no longer in the bloodstream? At the zeros, right? Does it look like our graph crosses a 0 here? Yeah, it does, like right about in here, right? And so what we'll do is use the 0 command there. So second trace, go to 0, hit enter, okay? We need to be to the left of our 0. At any of these points right here, I'm to the left, so I'll just hit enter. Then I'll use my right arrow key to move to the right of my 0. It's going to take me some time here. I can tell I'm to the right of my 0 because my y values are now negative, so I can hit enter there, and I'll move in close to the 0. So it looks like it's like right around in there. I'm really close to 0. And so I get about 6.63. It says round to the nearest hundredth. At t equals, and I'll put a squiggly equals sign for the approximate, 6.63 hours. Okay, squiggly equals means an approximation. And finally, it asks us to state a reasonable domain for the function in the context of the situation. Okay, so domain describes what variables? X's or Y's? X's. So in this case, what variables like are X's? C's or T's? Which variables like are X's here, folks? C's or T's? The T's, right? Okay? So we need to come up with a reasonable domain that is reasonable times, okay? So what would be a reasonable time for us to start in the context of the situation? What would be a reasonable time to be starting at? 0, right? It would not make sense to go to negative infinity, right? It would make sense to start at 0. So we'll say from 0 to, and then what do you think is the farthest time amount we should go to for a reasonable domain? So infinity, potentially, but I think there's a more realistic one in the context here. Yeah, go ahead, Mike. Or Braylon, what are you saying? 7? So 7, or you could even say if you wanted to, 6.63, right? So something that's like right where it hits 0, right? Because we don't really care about, the drug's gone completely from the system. And in this case, we're really trying to analyze the concentration. So I would say 6.63 is the best. If you want to say 7, though, just kind of like, get a nice round number, I can see your thinking there. I think 6.63 is probably, fine too. Stop there. Okay? So again, this is where the starting point where you take the drug, and then this is the part where the drug is completely gone from your system. Okay? And again, in a realistic context, this makes some sense, right? Because, most medicines, right, you have to take, every 4 to 6 hours or something like that. And so that makes sense. After about 6 hours, the medicine is completely gone from your system. You need to take more if you want to get the effects still. Okay? All right, questions on that one? Mm-hmm. Had some trouble? Okay, show you here real quick then, one more time. So there's the 0 right there, you can see it. So you press second trace and then the 0 command, okay? For the left bound, make sure you use your left and right arrow keys and just make sure you're to the left of the 0, anywhere. I can tell I'm to the left of it because I have positive y values right now, so I hit enter. And then for the right bound, I want to go to the right of my 0, which means I need to see if I'm negative, and there I can see I'm negative now. So I'll hit enter. And then for the guess, just go in towards the 0, and I think the closest I can get is like 0.003. I hit enter there, and then there's your answer. It should be 6.63, like I said. All right, turn the paper over there, folks. We'll take a look now at number 17. Okay, another little free response question here, baseball related. Okay. So let's see here. And you can use this too to kind of see, if you play baseball and like keep track of your batting average, you can see what it would take here to improve. Johnny plays baseball for Urbana High School. All right, no offense here taken, folks. It's just the author wrote this, whoever wrote it, not me. Johnny plays baseball for Urbana High School. So far this season, he has gotten a hit 3 out of 9 times at bat. He is determined to improve his batting average if he can get X consecutive hits. So that means, hits in a row kind of thing. His batting average can be determined using B of X equals 3 plus X over 9 plus X. Of course, that changes if you get some hits and you don't get some hits and stuff like that too. Okay, but if you can get X consecutive hits, this is how his batting average would change. Okay, so letter A tells us to identify all asymptotes. What kind of asymptotes are we familiar with? We should be able to identify any vertical or horizontal or potentially slant, right? So any of those 3, right? This is not being specific here. It's just saying identify all asymptotes. So let's see if there's any vertical asymptotes here first. Okay, so looking at our function right here, will we have a vertical asymptote? Yes, where? What X value would cause us to have a vertical asymptote here? -9. It'll make us undefined. So X equals -9. Okay. If you are uncomfortable, right, you can also try and graph this too. Remember, you put parentheses around the numerator, parentheses around the denominator. Okay, graph it. Okay, and you can see here, there's like a teeny little part of that graph, and there's some more graph right there. And you can try and identify that vertical asymptote. And I can see it probably goes through this point right here, which is, well, it's hard to see. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 9. Okay, or -9, I should say. Okay. You can also go to your table. And there at -9, you see you have that error there. Okay. And with the error showing up in the table and that vertical asymptote, you can see, okay. Or the space there, you can see it's a vertical asymptote. What about horizontal asymptotes? Do we have any of those? Well, what's the degree of the numerator? What's the degree of the numerator here? 1. What's the degree of the denominator? So it's the ratio of the lead coefficients. Be careful here. Yeah, it's 1, okay? The ratio of the lead coefficients is 1. So it'll be y equals 1. But Mr. Widmeyer, the 3 and the 9 are out front. But those aren't the lead coefficients, right? Because this is not written in the standard kind of form there, right? It should be x plus 3 over x plus 9. Okay, so 1 over 1 there. And so that's why you get a horizontal asymptote of y equals 1. You can also see it in the graph. Okay, find the 0. Well, again, you can go to your graphing calculator if you want to and use the 0 command. You can kind of see where it crosses. Heck, you might even be able to count that. 1, 2, 3 kind of thing. But let's do second trace, 0 command. Go to the left of your 0, hit enter. Go to the right of your 0, hit enter. Go in for the guess and hit enter. And then you can see -3, 0 confirmed. Okay. Of course, you can also set your function equal to 0. Okay, and a fraction only ever equals 0 when the numerator is 0. So then you can just set x plus 3 equal to 0, and you can see, yeah, x equals -3, which is what we get right there. Okay. Find the y-intercept. Okay. So the y-intercept occurs when we cross the y-axis. Okay. How can we find the y-intercept here? Any ideas? What can we do? How do we know when we cross the y-axis? There is not a command here that tells you directly the y-intercept. I mean, you can still do it using the value command there, actually. But anyway. So any ideas? What can we do here? How can we find the y-intercept in this graph? So yeah, Mike?
I put it in zoom box.
Oh, zoom in on it. Okay, yep, we can do that. I'm going to tell you right now it's going to be hard to see because it's going to be a fraction. So it's not going to like cross through a nice number, we'll say. It's going to be a fraction. But that would work too. You could like zoom in on some. What else could we do? How can we find the y-intercept here? Well, we can go to our table. Okay. Where are we looking on our table to find the y-intercept? If we cross through the y-axis, what will our x-coordinate be? Anytime you cross through the y-axis, what's the x-coordinate? on the y-axis? 0. So if we look at the x-coordinate 0 there, we can see there's the y value, 0.33333333, which is 1/3, right? 1/3. Okay. Another way to do this is you can plug in 0 for your x values. Okay. So just like literally just do b of 0 here, and so you'll have 0 plus 3 over 0 plus 9, which is 3 over 9, which simplifies to 1/3. And so it's 0, 1/3 is your y-intercept there. Okay. And then we can go ahead and graph this, and we have some information right here to graph already. We have the vertical asymptote at -9. So let's see here. These are counting by 2, 4, 6, 8, so -9 would be halfway right there. Okay, horizontal asymptote at y equals 1, so that's going to be halfway right here. Okay, they didn't really give us a good place to graph this, I think, but anyway. So again, VA x equals -9, HA y equals 1. Okay. -3, 0 is the 0, so -3 would be right here. And the y-intercept is 0, 1/3, so there's 0, and then 1/3 would be like right here probably. So that gives me enough to basically go like this, and then like this. Okay. And there's more graph over here too, but it's kind of hard to see. Let's see, -10, what would that value be? So there's the -3, 0. Okay, that's our 0, right? And there's 0, 1/3 right here. Okay, -10 gives me 7. So here's -10 right here, and that gives me 7, so that'll be up here. So my graph's going to look something like that. Okay, didn't give us quite enough graph there. Excuse me. Okay, so next question asks, what's the range of this function in context of the situation? Okay, so range describes the what values? Y values, okay? But in the context. So what's the lowest y value that would make sense in the context here? What do you think? What's the lowest y value that would make sense in the context here? So we could say 0, right? Because it certainly does not make sense to have like a negative batting average, okay? But here at 0, okay, here's where we have our y value of 0. At 0, the number of consecutive hits we have would be -3. So yes, the range might make sense to have a batting average of 0, right? There's, that first baseman on the Orioles had a batting average of 0 for a while there. But in this case, right, it would make more sense to actually start right here because this is, after 0 consecutive hits. So what is the y value right here? 1/3. So it actually is going to make more sense here to start with 1/3 and then go up to, and then what does it look like the batting averages? What are the y values approaching here as we go along? So what's the y value? What's the y value we're approaching here as we go along? What does a batting average approach? For those of you that play baseball, what's the highest you can get? What's the highest batting average you can get? 1, right?
0.99.
0.99, right, exactly. We're not going to actually get to 1, right? We can't get to 1, so it'll be closer as we possibly can get. So we'll put a 1 there in parentheses. Okay? It's impossible to get to a perfect batting average because this person already has 3 hits out of 9 times at bat. So it's going to be impossible for them to get perfect, but they can get really close to 1. Okay. And then last but not least here, letter F asks us to interpret the meaning of b of 4 equals 7/13. So this goes back to our function right here. It's giving us a value. It says, okay, well, if x happens to be 4, then your value will be 7/13. So what does that 4 represent here? 4 is a number of what? It's replacing x, right? And what does x represent in this problem? Number of consecutive hits. Yeah, so after 4 consecutive hits, okay, because that's, again, 4 replaced x, which is the number of consecutive hits. After 4 consecutive hits, Johnny's batting average will be what? 7/13. Okay, which if you want to put it as a decimal, because that's the more traditional way, is 0.538. Normally the batting average is 3 decimals, right? So there you go. Questions on any of that? Okay, so I'll quickly compile this video, put it together here, post it to our Google Classroom so you guys can review it if you need to.